This is the practical one and the theoretical. So actually, this is the wave, and there's a free end. Sorry, rigid end. Let me write it subheading. So this point P is a rigid end. Okay, it's not a ring. Some of you will get confused. Understood? If I just say wall, rigid wall, it is understood here. Now the wave pulse will arrive. We know just now we have discussed, no? The point P will not move. Then what will happen to the wave? Finally, it will become horizontal. What all we discussed just now, the same thing I'm going to repeat. Here I'm going to introduce one alternative method to know the shape of the rope. We need not to depend on the method what we learned just now. No. I think to predict the shape of the rope, you should be very good in what, like the observation. No, you should have very good knowledge of physics also. Blindly you can't. Okay, design the total energy U plus K U equal. I am very particular about these things. Huh? Okay, when a wave reflected by a rigid wall, this is what happens. Every time drawing the shape of the rope will be very difficult. We will go for one graphical method. In the graphical method, what is telling? If an erect pulse arrives at a rigid wall, if an erect pulse arrives at a rigid wall. So what graphical method is telling is, you assume another an inverted pulse. Color, contrast color. Let me take contrast color. There's a real pulse, real erect pulse. There's a inverted imaginary pulse. So for our understanding purpose, we will give color so that it'll be easy for us that what we are studying. Again, that color is only for our understanding purpose. The yellow color is nothing. Only it's a graphical way of showing that it's a pulse. Now, what is suggesting is like, what is that pink color? Uh, okay, this is the assumption is what is asking. What is the pink color one? It's an imaginary one, nothing to do. So when both the pulse will arrive here, let me take superposition as if this rod is not there. Let's not bother this rod, as if this rod is not there. Then at one instant, I think I can move this part. Yeah. They'll undergo superposition like this. And finally, they will look at the shape of the rope, how it should be. So this is plus A, this is minus A. What is the net displacement of this point? Will be zero, no? I'll put that. Sir, why you are putting zero? I'm just taking the graphical method. Plus 2 centimeter minus 2 centimeter. What should be the displacement? Should be zero. Plus 1 centimeter plus 1 should be zero. 0.5 plus 0.5 minus 0.5 should be zero. Like that, what is the displacement of any point on a rope? Will be zero. I think as a practice, I have to show the rope here like this. Then in what action there's a real pulse, it is like this. Then finally what will happen is like the real pulse will be on the I'll move a little bit down. Dotted one, I have to write it. Imaginary, it will be. And finally, after some time, I don't have space. Huh? After some time, this pulse will be here. Okay, we can draw it one more diagram. O is real, O is erect. I think that there's some confusion with it. I'll put it no. This will be real. I written this one. Yeah. You have complete description. There are two methods are there for you to draw the shape of the pulse, shape of the rope string. You should be very good in the basics of physics to predict exactly the shape of the rope. Why here the rope is horizontal? Why the rope is horizontal? It's because of this phenomena. But here I think I'm very clear. No, why the rope is horizontal? Plus a minus a. What is the net displacement? Zero. Plus 1 centimeter minus one. Displacement of this point is zero. 0.5 plus 0.5 minus 0.5 plus 0.2 minus 0.2. What is the displacement of any point on a rope in this region? Will be zero. Therefore, the rope is horizontal. Then this is like a graphical method. This is what actually practically happens. What is this? This is a graphical representation. What is telling? If a erect pulse approaches a rigid wall, what you should do? If an erect pulse approaches a rigid wall, what you should do? Instead of using this method like the point P, tension will act, since it's a rigid, it will not shift. Simple. You imagine another inverted imaginary pulse. This is erect, we call erect state. Inverted pulse, you imagine. Take superposition of those two. Then we can say at one point it will be rho will be zero. We can predict the displacement of this point also. So this will have plus 1.5 centimeter, 0.5. So this will be 1 centimeter. So that's why the rope will have some displacement. Like that, we can predict all the thing. Finally, what will happen? Now this will become real. This will be like a imaginary. This is a graphical method. The imaginary pulse only when it crosses the wall, what will happen? It will become real. Sir, means you mean to say that whenever I stand nearby a like this, I'll take a rope, I'll put a knot. As I start vibrating, as I give a jerk, will there be some other person on the other side of window, imaginary person, imaginary rope, where it will generate a pulse? No, nothing. If you're thinking like this, is a stupid brain. Finish over. If you stand here, if you put a jerk, only you are here. Why your imaginary person will come? Physics will accept like that. Nothing. No, don't think that another imaginary person, imaginary rope, he will generate a pulse. Nothing to do. You are generating a pulse, pulse will go, get reflected, inverted pulse will come. What is then, sir? Then what is this inverted? It's a graphical method. I can now give explanation. Why rope horizontal? Plus a minus a. That's why rope horizontal. And why it will get inverted? So when this pulse crosses here, yes, the reflected pulse will be inverted. Getting the idea? This is a graphical representation. That's all. So I do prefer this to analyze. This is imaginary. Now this will become imaginary. Are you getting? Now this will become real. Any doubt, please do clarify because our topic is based on superposition principle. Let me have water. Okay, now let me continue. Similarly, sir, can you show any graphical method to predict the shape of the rope for a free end, reflecting the free end? Yes, we have that one.